All right, students, I'm going to help go over some stuff from the 7.3 puzzle time worksheet. And part of what it is some of them are similar to stuff we've done and some of them are not. So the first four are sort of patterns that we can figure out because they gave us the whole sequence, and you just got to figure out what the multiplier is. Okay. And in most cases, it's pretty straightforward: times 3, times 3, times 3, or times 2, times 2, times 2. Now, in this one, if it flips from positive to positive to negative, something weird is going on. Well, also what's going on is it's getting smaller by a half, by a half, by a half. So it's times a half, but how do we get this negative thing in here? Well, if you times it by a negative 1/2, then the first time negative 1/2 will give you negative 50. When you do that again, a negative negative turns back to a positive. Positive times a negative is a negative. Negative times a negative is this is a negative. So negative times a negative is a positive, and so it flip-flops. All right, so same sort of thing there. For these ones, what it is, they didn't give you the first term. Again, what we need is to write a formula. We need the first term and multiplies by the ratio, and it does that n minus 1 times. Okay? What they gave us here is they didn't give us the starting one, which we need. They gave us A3. So what we know is it's 12, and they gave us R2, so R equals 2, so we know it's timesing by 2, so the next one would be 24. Okay, and then times 2 times 2. So times 2 to go this way, working backwards would be dividing by 2. So dividing by 2 would give us 6, dividing by 2 would give us 3. That's our first term. So now we can say it's 3 times 2, and it does it n minus 1 times. All right, that would be our formula right here. Okay, and the rest of those ones are the same. What I want to sort of help you with is later ones like number 9, because that's different. They didn't give you the ratio, and they didn't give you the starting term. We need either the ratio or the starting term, the A1. They gave us neither. So I'm going to need some scratch paper here, so let's write this down. A2 is 8, and A4 is 32. Okay, so we're going to go through this two ways. One, we can logic our way through it. The numbers might be easy enough to figure it out. Or two, we can algebra our way through it. Okay, so they gave us 4 terms, or not really 4. They gave us 2 of the 4 terms. They give us the fourth one is 32, and the second one's 8. So again, that's A1, A2, A3, A4. So A1 would be the first one. A2 is 8. A3 would be whatever's here. And so what you got to do is figure times something gets us to here, and then times that same thing gets us to 32. And there's really only one obvious answer here, because this one is actually a whole number. If you multiply by 3, that'd give you 24, and then it'd be way too big. If you multiply by 5, that'd give you 40, already too big. The only choice here is timesing 2 to get 16, and then times 2 to get 32. So we can tell it's times 2. But what if they hadn't given us that one? If they gave us some way, way down the road, we need some other method. Okay, and plus we're math 3. We want to be able to do some algebra here. So what we're going to do is we're going to say, okay, our formula says this: A1 times R to the n minus 1. Okay, and we're going to have, let's set up this for an equation. We'd say A4 is 32, so 32 is equal to A1, which we don't know, times R, which we're assuming we don't know yet. But the n, when it's A4, your n is 4. So we can simplify this and say 32 is some A1 times some multiplier to the third. Again, all we did is plugged in the values we had. We knew it was 32 for the fourth one. That gives us an n value of 4. The other equation we're going to do, A2 equation, we can say, we can say 8 equals A1 times R. And this is the second one, so it's to the 2 minus 1. All right? So that's 8 equals A1 to the R, or A1 times R to the 1. Okay, well, what do you do with these two things? Well, we got 2 equations, we want to combine them into one. So you can add equations together, you can divide equations, you can do anything you want, as long as what you're doing is equal on both sides. What I mean is, if we start with this equation, and said 32 equals A1 times R to the third. So for example, we could divide both sides by 32 if we thought that would help. Let me move this up here for a second. We could divide both sides by 32. We could divide both sides by A1 if we thought it would help. It won't. I'll tell you that right now. So whatever we're going to divide, if we divide something here, we gotta divide it here. Well, let's choose 8 to divide by. Why 8? Well, we need to divide 8 by here, but wait. 8 is exactly A1 times R1. So we can divide these two equations like so. The top part is just this equation. The bottom part is this equation. And when we divide them, here's what's nice. That gives you just 4. The A1s cancel out, and the R's cancel. One of these cancels with one of those, and you have R2 on top. So you have R squared equals 4. Well, if R squared equals 4, then R must equal just 2. Okay? That doesn't answer our question. We need to know A1. We know R now, and we know it's to the n minus 1. We don't know A1. But we know our multiplier ratio, R is for ratio, but it's also a multiplier. We know our ratio is 2. So if this was 8, then we know this must have been 4. So we can go times 2 to get to 8. This is 8, we're going to go times 2 to get to 16. And so on and so on and so on. All right? So we know our first term is 4. We know our multiplier is 2. We can say an equals 4 for the first term times our multiplier to the n minus 1. All right, that's it. Hopefully that helps with the other ones, and it doesn't have to be A2 and A4. It can be anything, and this method still applies. And that's what's nice. They can give you the 5th one and the 50th one, and you can still work those out. All right, so try that out, follow along, and if it's still kind of confusing, bring questions tomorrow. Alrighty, there it is. Have a great day, you guys, and I'll see you in class.